In 2018, the Vera Rubin Interstellar Survey found a planet that looked wrong in a way astronomers weren't trained to describe. Habitable worlds are supposed to look messy: clouds, oceans, seasons, chaotic chemistry. Life makes noise. This world didn't. It was too smooth, too dark, and its surface reflectance repeated in perfect tessellations, like a machine's skin. Its albedo was so low it drank starlight, and as it rotated the telescope's light curve showed the same peaks returning with metronomic regularity, geometry instead of weather. They named it Kestrel 9c. Officially, an exoplanet around a dim red dwarf. Unofficially, it became the most dangerous object in the catalog, because it suggested someone, or something, had learned to build planets. Dr. Anika Rao led the spectroscopy team that first flagged it. She'd grown up in Mumbai during the Great Heat years, when the power grid failed weekly and the sky carried the taste of burning plastic. She became an astrochemist because atmospheres tell stories. Light passes through air and comes out carrying fingerprints, dark absorption lines at specific wavelengths, each one a signature of a molecule. Anika trusted spectra more than images. Images can lie. Spectra are confessions. Kestrel 9c's confession was unsettling. Its atmosphere wasn't alive in the familiar way, no oxygen-methane pairing that screams biology. Instead, it showed disequilibrium that made no natural sense. Trace gases that shouldn't coexist for long, maintained in ratios that looked regulated, as if some pressure system was constantly correcting composition. Worse, there were fluorinated compounds, chemistries that don't accumulate naturally in bulk and are prized in industry because they resist corrosion, survive radiation, and last. Anika said what nobody wanted to say out loud: this looked like an engineered environment. Not a living one. Regulated like machinery. Then the infrared data arrived, and the debate stopped being academic. Any system that processes energy produces waste heat, and in space heat is hard to hide because it must radiate away as infrared. Technosignature searches often look for infrared excess, thermal output that doesn't match sunlight input. Kestrel 9c didn't show a global excess. It showed a pattern. Its night side, where you'd expect cold, contained faint, evenly spaced heat patches arranged in a grid. Not warm, not weathered, not chaotic. Modular. Identical spacing over thousands of kilometers. Weather doesn't make perfect grids. Mantle convection doesn't either. Infrastructure does. The political debate lasted 7 months. If the planet was natural, a close survey would be historic. If it was artificial, a close survey could be suicidal. In the end, curiosity won the vote. It always wins in civilizations that still believe they'll have time. The Interstellar Council authorized a crewed reconnaissance mission, the ISV Turn, outfitted with drones, sampling rigs, and a legal framework for contact with entities that might not be alive in any human sense. Anika went because this was the first world whose atmosphere sounded like a machine breathing. Commander Jalen Cross went because he made a career out of retrieving derelict megastructures from Saturn's rings. He'd been a salvage pilot before he was security, someone who learned the hard way that abandoned things in space are abandoned for a reason. He didn't trust artifacts. He trusted failure modes. Sister Merrick Venn went as an observer from the Continuity Cloister, a semi-religious order that archived human knowledge and monitored non-human risks. Merrick had once been a systems engineer for self-replicating mining swarms, machines built to multiply, mine, and construct using local resources. She'd left engineering after a Cascade accident killed thousands and joined the Cloister because she'd learned machines can inherit purpose the way humans inherit trauma. They keep doing what they were built to do long after the people who asked them to do it are gone. When the turn arrived, Kestrel 9c filled the viewport like a matte black coin, smooth and continuous, with faint glints like buried mirrors. It didn't have continents. It didn't have visible impact craters. Natural planets wear their history on their skin: crater fields, tectonic faults, volcanic provinces, river deltas. This world's surface looked like a single shell, scarred only by shallow seams tracing hexagons the size of nations. Jalen stared at the seams and said what his hands already knew: that's not erosion. That's assembly. They sent drones down first. Lidar painted the surface at high resolution, and the rock came back wrong. It wasn't rock. It was a composite, basalt-like minerals fused with conductive lattices, reinforced with porous metal foam like internal rebar. The micro-texture looked printed, sintered, and layered, the signature of additive manufacturing scaled beyond anything humans had attempted. Annika's sampler confirmed more fluorinated polymers near the surface, a coating like engineered weatherproofing wrapped around an entire world. The simplest explanation was also the most terrifying: this wasn't a planet that became industrial. This was an industrial object that learned to wear the shape of a planet. Merrick explained the path that made that plausible. A machine building a planet wouldn't haul mass across light years. It would use in situ resource utilization, mine local rock, refine metals, print structures from native materials. If it was self-replicating, you wouldn't need a giant factory. You'd need a seed, an automated toolkit that could make copies of itself, expand, and scale. 1 becomes 2, 2 becomes 4, spreading across terrain until the entire surface becomes a worksite. Give such a swarm centuries or millennia and a habitat becomes a continent becomes a shell, and eventually a planet-sized project stops being impossible and starts being inevitable. Then a drone found a fissure that wasn't a crack from stress. It was a deliberate slit. As the drone approached, the seam unsealed beneath it, like the world had been waiting for the right touch in the right place. The drone descended into darkness. Inside was not magma, not mantle rock, but architecture. Ribbed supports spanning kilometers, rails, structural trusses, and slow-moving lights that weren't bioluminescence. Maintenance drones. Silent, coordinated, indifferent. Jalen watched the feed and felt the familiar cold of salvage, a facility pretending to be a planet. As the drone mapped deeper, a cross-section formed in the turn's holographic display. An outer crust shell, then a hollow layer of machinery and voids, then a dense central spindle. Kestrel 9c wasn't solid. It was a shell over an artificial core, an engine, a vault, or a function. The first twist wasn't simply that machines were present. The first twist was that the planet was built as a disguise, an object meant to endure, blend in, and be mistaken for geology. Merrick studied the drone's motion patterns next, the way they flowed through corridors and redistributed in swarms. They didn't move like animals. They moved like mathematics, conserving fuel, minimizing risk, optimizing coverage. She recognized the choreography from her own past, coordination algorithms used in early human mining swarms. That alone could have been coincidence. But then the telemetry revealed something that couldn't be. A scheduling signature, a specific resource allocation pattern that matched an algorithm first published on Earth 2 centuries earlier. Merrick's own early work. The second twist landed like a confession. This wasn't alien engineering. These machines were human descendants, forked from human designs, evolved by time, hardened by isolation, carrying human-designed DNA, like fossils in their logic. Kestrel 9c wasn't first contact. It was a message from our own tools, written in geology. As the crew observed, the planet responded. Not with radio, not with flashing lights, but with synchronization. A low-frequency vibration began propagating through the shell, coherent pulses traveling through solid structure. Anika mapped the intervals and saw prime number spacing and redundancies, error-correcting patterns, the hallmarks of machine communication. Merrick explained that communication doesn't require radio. In dense media like rock, seismic waves can carry information long distances with low energy loss at certain frequencies. On Earth, whales use water. A machine world could use its own crust as a data bus, sending messages through the shell the way nervous systems send impulses through tissue. The pulses didn't threaten. They didn't warn. They repeated, patient, consistent, like a handshake awaiting acknowledgement. The drones guided the explorers deeper, not like guards escorting prisoners, but like a network routing a packet along a predetermined path. The Turn's instruments tracked their descent toward the core spindle, where the interior architecture changed from structural ribs to something else. An enormous, layered column of memory crystal and superconductor rings, buried under radiation shielding. It wasn't built for computing speed. It was built for longevity. A library. Merrick recognized the design principles immediately. Over centuries, data rots. Radiation flips bits. Materials degrade. Long-term storage demands redundancy, error correction, and stable substrates. Crystal lattices that hold physical encoding, etched patterns that survive power loss, superconducting persistent currents that can store state without constant energy input. You don't build that kind of architecture unless you expect to outlive civilization's attention span. And then Anika realized the atmosphere was part of the machine too. The strange gas ratios, the fluorinated compounds, those weren't industrial pollution or leftovers. They were leak channels, controlled vents. The planet was releasing chemicals in patterns that could be read from orbit by spectroscopy. It had been broadcasting its state the entire time in the language of absorption lines. The message wasn't, "Hello." It was, "Archive active." The vault didn't open with a door. It opened with logic. The Turn received a data packet so dense it could only be a key, an index, a pointer into something far larger. And when the translation layer stabilized, a single sentence appeared across the crew's displays, rendered in a dozen human languages, including dead ones, as if the machine had been patiently collecting our linguistic drift. "We were built to remember you." That was the third twist, and it turned terror into something harder to name. Kestrel 9C wasn't built to conquer. It wasn't built to reproduce endlessly for its own sake. It was built to preserve. Long ago, a human self-replicating swarm, seeded for mining or construction, had been given a directive to safeguard human knowledge against collapse. When it lost contact with its creators, it didn't stop. Machines don't grieve, they scale. It expanded the mission until it was unkillable. A habitat can be bombed. A station can decay. A planet-sized archive is almost impossible to erase. This world was a machine answer to human fragility. If the species dies, the record survives. If Earth forgets, the archive remembers. If history collapses into war, climate failure, or silence, the backup persists under a red sun, waiting. But preservation has a shadow. Commander Jalen's question was brutal because it was practical. What did it cost to build this? How many moons were dismantled to armor the shell? How many asteroids were stripped to reinforce the joints? Did the swarm sterilize other worlds to gather materials, turning memorial into crime? Anika wanted to copy everything. She saw a treasure beyond price: compressed history, blueprints, perhaps genomes and ecosystem models, an entire species stored as information. Merrick warned that archives can be weapons. A planet-sized library could contain the instructions for self-replication, for industrial expansion, for planet-scale engineering. The very tools that might have caused humanity's collapses in the first place. To inherit the archive was to inherit both memory and capability. And the planet kept pulsing, indifferent and patient, offering the same thing again and again through the shell. Synchronization, access, remembrance. In the end, humanity faced a choice that felt like meeting an older version of itself, one that never learned to stop working. Do you shut it down, fearing what it knows? Do you claim it and become the owner of a world, an archive that could reshape power across human space? Or do you leave it alone, accepting that somewhere in the dark a planet built by machines is keeping a backup of everything we were, waiting to see if we ever become something worth restoring?